Assalamualaikum and hi, my name is Nurnaili Maisarah Binti Zulkifli, and I'm going to talk about the type of converter that we chose and the reason why we chose this converter for our application. So for our application, which is the lighting system, we have decided to choose boost converter for this application, and here is the reason why. But before that, what is actually a boost converter? So, boost converter is actually a DC to DC power converter that is used to step up the voltage from the input to output. So basically, for example, if the input of the voltage is 3 volt, and we wanted an output of 13 volt, this is when the boost converter is used. So as we can see right here is a basic diagram for boost converter. So boost converter design actually consists of 4 main components, as we can see here, which is inductor, power switch, could be MOSFET or IGBT, diode, and capacitor. So how does a boost converter works? Let's see. So in boost converter, the current will flow in two paths, which is when the switch is on and when the switch is closed. So as we can see right here, during the on state, which means when the switch is closed, the current will flow only through the inductor and allows the inductor to store some energy. While when the switch is open, which is during the off state, the current flow will be reduced as the impedance will go higher. So when the current is reduced, the voltage will be higher in order to charge the capacitor through the diode. Therefore, the output voltage will be higher than the input voltage. So this is why boost converter is used in the lighting system application. Well, actually, lighting system is a battery powered application. So let's say, for example, we have LED, which needs typically around 3.3 volt to emit light. So with the use of boost converter, we can only use a 1.5 volt battery instead of a 9 volt battery, since the boost converter will help to step up the input voltage to the desired output voltage.
To implement in the application. So as the application, we choose lighting system, where nowadays many securities and emergency light system application use lead acid battery to provide power during a mains power failure. So apart from that, this application also used in LED or a dimmer light system. So why did we choose to implement the boost converter inside the lighting system? What is the purpose of it? So the purpose of it, first of all, this boost converter only need a low voltage source, as it can boost up the voltage itself. As for the second one, it can save cost. Save cost means that although this boost converter is not as cheaper as buck converter, but it is more advantageous and affordable. The advantageous part is where the voltage output can be boosted up, although the voltage source is in a lower voltage. So as for the third, it could save energy, and for the fourth, it could save life, where if the system could save energy, of course it would save the life of the system, so that the system could be used for a long term, and this could also connect it to the earth go green. So many of us loves this kind of campaign, that go green earth and all. So by using the boost converter inside the lighting system, we could upgrade or even increase the earth go green for the earth.
Assalamualaikum, my name is Muhammad Haiqal bin Halim. Today I want to present about our group result and simulation of DC-DC switching boost converter. This is our circuit schematic diagram of boost converter used in PS5. A DC-DC switching boost converter will take a 5 volt DC voltage supply and deliver 15 volt with a load of 6 watt. Specify the required value of the duty ratio, minimum and maximum current value, inductor value and capacitor value with the output voltage ripple less than 0.5%. Assume that the switching frequency is 50 kHz. The boost converter is divided into two modes, mode 1 and mode 2. Mode 1 begin when transistor M1 is switched on at time t equal to 0. The input current rise and flow through inductor and transistor M1. Mode 2 begin when transistor M1 is switched off at time t equal to 1. The input current now flow through inductor, capacitance, load and diode. The inductor current fall until next cycle. The energy stored in inductor flow through the load. Okay, this is our output waveform of boost converter. Figure below is the output voltage waveform of the boost converter from PS5 simulation. The output voltage across the resistor R1 become stable after some time and remain at 15.49 volt. Okay, from the output waveform we get the value of output voltage and input voltage from the simulation, and we get a different value from the theoretical measurement measured. Okay, for the voltage output is 15.491 volt, and the V input is 4.2116 volt. From the theoretical measured, we get the output waveform is 15 volt and the input waveform is the input value is 5 volt. Okay, we have the minimum and maximum current. From the figure below is the minimum and maximum current being at frequency 50 kHz. The maximum current delivered to the load will be 1.85 ampere. From the table below is we can see the maximum current is 1.8585 ampere, and we get the minimum current is 224 milliampere. We get from the theoretical measured, the maximum current we get 2.2 ampere, and the minimum current is we get 0.22 ampere. From the result obtained in the simulation of boost converter using PS5, it is clearly observed that the boost converter step up the voltage from 4.21 volt to 15.49 volt in accordance with the parameter derived early, fulfilling the desired condition of maximum current being at 2.2 ampere at frequency 50 kHz. The efficiency of the boost converter is 94.60%. Okay, The analysis data that we can make is the integrate circuit of boost converter is still require a voltage of 15 volt to function. The DC-DC switching boost converter will take a 5 volt DC voltage supply with capacitor value with the output voltage ripple less than 0.5% and deliver 50 volt to the load. The maximum current delivered to the load will be 2.2 ampere. The circuit will operate with a minimum of efficiency of 94.60%. Okay, that is our group simulation and result. Okay, thank you.